So now we move on to two more topics that are somewhat related to the ones we were just studying, called permutations and combinations. We're first going to define what permutations and combinations are. We're going to find some formulas for the number of permutations and combinations in a given context. And then finally, we're going to try to understand permutations and combinations in terms of what happens when we change the order of the objects. That'll be especially helpful when we're trying to tell the difference between the two concepts. So imagine you have a set with n objects in them, and let k be some number less than or equal to n. Here are two counting problems that are kind of similar to one another, but a little bit different as well, that you can create from this situation. So first of all, this one should be familiar. How many ways can you choose k objects from your set and collect them just in a bag? And the second one is, how many ways can you choose k objects from your set and then line them up in order? So in the first situation, once you have selected your k objects, your counting is essentially finished. You don't have to worry about what order that you chose them or anything like that. Once you've chosen them, you're all done. So this is called a combination. The second situation is, once you have selected your k objects, you're not done. You have to, in fact, count all the ways you can arrange those in order. And this is called a permutation. So a permutation is a set of objects is a way of arranging those objects in order. So if I want to take the set A, B, C and arrange all the objects in order, in other words, find all the permutations, this one isn't so bad, right? So you can arrange them B, then A, then C. You can arrange them B, C, A, C, A, B, C, B, A, C, B, A, B, C. And so you get 6 permutations. And notice that in each of those, you are looking at the same elements in each one, but since we were able to arrange them in 6 different ways, they were each considered differently when we were talking about permutations. Now, you don't just have to make permutations out of an entire set. You can take a set of, say, 5 elements, A, B, C, D, E, and ask yourself, how can you make permutations with 3 elements? So you take 3 elements out of the set, not all of them, and then arrange those in order. So if you want, for instance, picked A, D, and E, you can arrange them D, E, A, or A, E, D. But you don't have to use those. You can use any 3 you want. B, C, and E, A, B, D, D, A, B, etc. There's a whole bunch of them. I'm not going to list them all. There are 60 permutations in all, as it turns out, for this one. So I don't really have enough room at the end of this slide. So now I'm going to introduce some notation related to permutations. So there are 2 things going on with permutations, right? There's the number of elements in your set, and there's the number of elements that you're choosing from that set to make your permutation. So that's why the notation has 2 variables. So P of nk is the number of permutations that you get from choosing k elements from a set with n elements. So for instance, if I want to find P10(3), I want to find all the permutations where you have 3 spots in each permutation, that's what the 3 means, and you're choosing objects from 10 elements, that's what the 10 means. So there are my 3 spots, and now I'm going to count the number of ways that I can line them up in order. So since I'm going in order, I can go from left to right, and I'm not going to have any overcounting issues. So if I want to ask myself, how many objects do I have available to put in the first spot? Well, I can put any of the 10 elements in there, so I have 10 choices. Now, once I've made that choice, I have 9 choices that I can have for the second spot. And once I've made those first 2 choices, I have 8 ways that I can choose the third object. And that's it. To figure out what P10 and 3 is, I just use the multiplicative principle. I get 10 times 9 times 8. That gives me 720 permutations. So in general, the reasoning is going to be just like it was in that example. Right? I have k spots for each permutation, and I'm going to choose the objects from n elements. So there are my k spots, 1, 2, 3, ... all the way to k. So how many choices do I have for that first spot? Well, I can choose any of the n elements in there. Once I've chosen that first one, I only have n minus 1 choices for the second spot. Once I've chosen those first 2, I have n minus 2 choices for the third spot. I keep on counting down. My last factor is going to be n minus k plus 1. And so when I find P of nk, I'm just going to use the multiplicative principle again and multiply those all together. Now, if I don't like the dots in that formula, I can do kind of what we did in the binomial coefficients. I can look at it as a fraction and multiply top and bottom by n minus k factorial. That'll give me n factorial on the top, n minus k factorial on the bottom. So now let's move on to combinations. So C of nk is the number of combinations that you get from choosing k elements from a set with n elements, and you don't worry about what the order is. You don't care about what the order is. So for choosing k elements, well, you know what? That's exactly the same as choosing a subset with k elements, right? So your set has total set has n elements, and you're just choosing a subset with k elements. That's your combination. So Cnk is the same as the number of subsets with k elements out of a set with n elements, which means that Cnk is just a different way of saying n choose k. And that means that the formula for Cnk is exactly the same as the formula for n choose k, which is, well, here's the big numerator version of the formula. You take n times n minus 1 times n minus 2 all the way down to n minus k plus 1 and divide that by k factorial. Or if you would prefer to multiply top and bottom by n minus k factorial, you get n factorial on the top and k factorial n minus k factorial on the bottom. And now that we have a formula for the permutations, if you ignore that k factorial on the bottom, it looks a lot like the formula for the permutations of k elements out of a set of n elements. And so there's actually a relationship between C of nk and P of nk, and that is this. C of nk is equal to P of nk divided by k factorial. So I want to talk, before I set you off on the in-class activities, I want to talk a little bit about the similarities and differences between permutations and combinations. First of all, they're both similar in that they both involve selecting k elements from a set of n elements. It's only what you do afterward that makes a difference. So a permutation depends on both the elements that you select and the order in which the elements are arranged, or the order that they're selected, depending on how you look at it. Which means that if you take a set of elements and change the order, that changes the count in a permutation. However, in a combination, that only depends on the elements selected. If you change the order, that does not change the count of how many objects, how many things that you get in combinations. All right, so now I think you're ready to look at the activities that go along with this video. The PDF file is called Permutations and Combinations.